Hi all my dear students. Now we are going to see practical part of highway engineering. Today we are going to see practical 2 of highway engineering. Experiment number 2 is conducting a flakiness index test on the aggregate. What is the significance of this flakiness index test? Why we do this flakiness index test? Specification, let we study or go through the practical specification. The particle shape of the aggregate road metal is determined by the percentage of the flaky and elongation particle contained in it. In the case of gravel, it is determined by its angularity number. For a base course and the construction of bitumen and cement concrete road type, the presence of the flakiness and the elongation particles are considerably undesirable, as they may cause enhanced weakness with possibility of breakdown under a heavy load. Since if we are constructing a bitumen and a cement concrete road, then the flakiness and elongation particles should be less. Why? Because that particles will enhance and that will increase the weakness in the road. Because of the heavy load of the vehicle, the particle may be breakdown and it can be changed the shape. Therefore, we avoid the flaky and the elongated particles in this both the road. The round aggregate are preferable in a cement concrete road construction as the workability of the concrete increase. Because of this round aggregate, the workability of the cement concrete road will be increased, and that's why we prefer a round aggregate. The flaky and the elongated particles may have an adverse effect on a concrete and bitumen mix. For instance, the flaky and elongation particle tends to lower the workability of the concrete mixture, which may impair the long-term durability. Because of this flaky and elongation, flaky means it may be the particles is maybe it is fatty or it may be elongated, means its length is more or its width is more. We need a perfect aggregate or we need sometime a round aggregate to increase the workability of the road. Therefore, for a bitumen mix, the flaky particles are liable to break up and disintegrate during the pavement rolling process. In a bitumen road, for settling out or for compacting purpose, we use a roller. Under this roller, when we applying a roller on the various layer, it should not change their shape. It should change their shape to an required quantity only. Therefore, if it is changing its shape, that means the aggregate is not suitable for that type of road. The angular shape of the particles are desirable for a granular base course due to increased stability deserved from the better interlocking. If the aggregate is angular, then it will be good for our road because it will increase the interlocking. Because of this interlocking purpose, the stability of the road is obviously going to increase. Thus, the evaluation of the shape of the particles, particularly with the refer to a flakiness, elongation of the angularity, is necessary. Therefore, it is very much necessary whatever type of aggregate we are going to choose for a different type of a road, that particles we should study the shape, size, so that we get to know whether that aggregate is suitable for a road or not. Now, the relevant program outcome. Which all the relevant program outcome is going to be study. First is a PO1, that is a basic knowledge. What is a basic knowledge? We have to apply our basic knowledge like a basic maths, science or engineers to solve the engineering problem. That is known as basic knowledge. Then the second one, discipline knowledge. In a discipline knowledge, we have to apply only our discipline knowledge, that is only the core knowledge of our subject. Core knowledge means our core is civil engineering. Therefore, we are going to apply the civil engineering knowledge to solve our engineer's problem. Then PO3, that is experiment and practicals. The ability to plan and perform the experiment and practicals are used to and to remove the result or to solve that problem and to give the solution to that problem is known as experiment and a practicals. Then PO4, what is PO4? Engineering tool. What is engineering tool? For solving this practical we should know which all tools or which all technique we are going to use it, and with that we should understand the limit of our tools and techniques for using that. This is our engineer's tool. Then PO8. What is PO8? That is individual and a teamwork. Because this experiment is very big, the individual person can't perform this, so we have to perform in a teamwork. So how we are going to coordinate with your members, how we are going to coordinate with the leader, this all things we are going to with the help of this we are going to perform our experiment. Then the relevant course outcome. What is relevant course outcome? Perform the different test on a road material. And the practical outcome is conducting a flakiness index test on aggregate. What is flakiness? Flakiness means how much your aggregate, what is the size of aggregate according to a respect to a width of an aggregate. We have to consider here the width of aggregate. Then the competitive and the practical skill. This practical is experiment to develop the following skill for a industry. Identifying a competitively recommending the aggregate for the given type of road. By doing this experiment, we can recommend it that this aggregate has been used for any type of a road or not. For example, if we are, for example, if there is some aggregate, whether that aggregate can be useful for a bitumen road or not, we are going to see with the help of this experiment. And how we are going to say it means how we are going to identify it. For that, our IRC have helped us. How? Let's see. Our IRC, the IRC recommendation. The IRC have given some limits for a flakiness limit for a flakiness index, that is if it is a 15%, the maximum, if your flakiness is 15%, then we can use it for a bitumen and non-bitumen road. If our flakiness index 30%, 30% is a combination of elongation and the flakiness for a bitumen and non-bitumen road, and if our flakiness index is 35%, then that aggregate can be used in a concrete road. Then we are going to see the procedure of our experiment. First we have to sieve the given aggregate sample through and sieve specify in the observation table. That is, there is a different size of sieves. We have to arrange accordingly given in the observation table, and then we have to sieve the aggregate. After sieving we have to, before sieving we have to weight the aggregate. After weighting the aggregate, the whole weight of aggregate, then we have to sieve the aggregate. After sieving the aggregate, take a minimum 20 pieces from each sieve sample and measure its weight W in a gram. Now pass the each individual aggregate particles thickness wise through a various opening of a thickness gauges. In this, there's a different type of openings. If your aggregate is passing from 12 mm sieve and retain on 10 mm sieve, then the opening is different. For like that, the various opening is specified according to in sieves. Note down the weight of aggregate fraction passing through opening of various sizes in the observation table given below in W in a gram. The weight of aggregate fraction should be measured to an accuracy of at least 0.1% of a test sample. Calculate the flakiness index of a given aggregate sample, that is W1 upon W into 100 in a percentage. Now we are going to perform this experiment as we have seen or as we have studied in a procedure. So let's perform this practical. Before that, we should know the observation table. See, as you can see, the observation table, in a observation table there is a different size, there is a different size of sieve like 63, 50, 40, 31.5, 25, 20, 10, 12.5, 10. That is a passing sieve, and the retaining sieve is 50, 40, 25, 25, 20, 10, 12.5, 10, 6.3. That means we have to arrange our sieves like this. That is, if we are placing 63, then below that we have to place 50, below that 40, below that 31.5, below that 25, below that 20, below that 10, below that 12.5, below that 10, and at the least there is 6.3. Then we have to sieve it. After sieving, we will get to know the weight of an aggregate. Okay, so let's do practical. So let's do.
Hi everyone. For this experiment we have to take a sample of aggregate. Then after taking a sample of aggregate you have to weigh it. It should be 7.9 kg. Focus करें 7.9. After taking the aggregate weight we have to remove it and we have to sieve it. Okay, after sieving, remove the sieve and a cross sieve, then write it. On a sieve number, as you can see over here, this is sieve 25 and you can see the aggregate. We have taken 10 mm sieve. From a 10 mm sieve, we have removed 200 pieces. We have selected 200 pieces. Now we have to weigh this 200 pieces. Okay. Weigh this 200 pieces. Okay. The weight is 1.18. Okay, 1.18 we have to convert it into a gram because this weight is in kg. So we have to convert in a gram. Okay. Now we have taken the aggregate which is retained on 10 and passed by 12.5. The weight which we have taken, that is 1.18 gram. Sorry, 1.18 kg. But we need in a gram. So we have to convert in a gram. Multiply by 1000, we will get the reading 1180 gram. Okay. Now we will see W1. Okay. How we are going to remove or calculate in W1, we have to see further. Okay, then we have to take this sample and this is the gauge where we are going to see or we are going to calculate the flakiness index test. How we are going to see? First we have to see if our aggregate has been passed by 12.5 sieve and written on 10. So whatever aggregate we are taking, we are going to pass from this, whether we have to test whether it is passing or not. If it is not passing, we have to keep it aside. Then we have to take a second sample. We have to see if it is passing. Keep it inside it. Same we have to do it for your all the 200 samples. If it is not passing, keep it aside. If it is passing, it is passing. So we have to keep it not passing. We have to do it continuously till we don't measure all the 200 pieces. So now whichever the aggregate been written, we have to take it. we have to weight it. Sample which has been written. Now we have to weight it. It is 0.17. Over here we have to weight of an aggregate in each fraction passing thickness gauges. Therefore, our this was weight was 1.17 gram. Sorry, it is in kg. We have to convert in gram. Therefore, 1700. The same thing we have to do it for each and every seed. Okay, and then we have to write each and every radius. Okay. Now what we have taken all the samples weight, and then we have taken all the passing aggregate weight from the gauges, and then just we have to calculate. Means we have to only add each and every radius. Here also we have to add each and every radius, and then the flatness index formula is W1 upon W. What is our W1? W1 is 1009. Therefore here is 1009 divided by 8995. That is the total of W. Multiply by 100. Whatever value we are getting, that is your flatness index. Standard in percentage. That is 11.2 as per our criteria. If the flatness index value is 15% or less than 50%, we can use this type of aggregate in a bitumen or a non-bitumen road. This type of aggregate we can't use for a concrete road. Thank you.
As we have seen in the performance how we are going to do it. Now all this observation table is going to fill in the experiment, and now the result. This type of aggregate is used for a bitumen and non-bitumen type road because the value is very less. Therefore this is aggregate is used for bitumen and non-bitumen road because the maximum flakiness value we needed for a bitumen road, that is 15 percentage. Therefore our value is below 15 percentage. Therefore this type of aggregate we can use for a bitumen and non-bitumen road. Thank you everyone.